concept for GateSense was developed while working with physical therapists at Memorial Hospital in South Bend. When we first met with them, they expressed to us a critical need for a device to measure weight bearing in the lower extremities during dynamic movement, which would be applicable to patients with both encouraged and discouraged weight bearing restrictions.
So when you're trying to choose sensors to measure the weight, a few things that we thought about were really trying to make them thin so that they could fit in the sole of the shoe. So the patient wouldn't feel them, it wouldn't affect their gait, and it would be comfortable for them to wear this insole. So we looked at force sensors, we looked at pressure sensors, we looked at load cells, and load cells weren't really realistic with our budget. Pressure sensors, we didn't want to have to worry about the area over which the sensor was sensing, so we chose force sensors. And the force sensors that we chose were called Flexi Force Sensors by TechScan.
One of our first decisions was to use a shoe for our device rather than a boot because the shoe didn't affect the gait of the patient as much as the boot. The next decision was how exactly to attach the sensors to the shoe. We ended up using an insole as opposed to putting the sensors on the bottom of the shoe because it protected the electronics better and yielded a more portable design.
For our first iteration of the insole, we made it pretty thin. As you can see, it's very thin, very flexible, and right here you can see that we have 9 pucks, or that's what we call them. And the idea of the pucks was to make sure that we placed the majority of the force onto the sensors, which would be placed on this side. And we have little cutouts for all the sensors. The major flaw with this design was that the sensors went out of the shoe, outside of the insole, so it would have ended up being pretty messy and not very good for packaging. This is the second and final iteration of our insole. The major change from the first iteration is that it is much thicker. The basic design hasn't changed much. We still went with 9 pucks, albeit they're significantly thicker than they were on the first insole. And in this part we have all the sensors, as you can see, and they're no longer jutting out like they were in the original design. They're now all wired in parallel and they all stay within the confines of the shoe while also not being too tall so we can easily package it. And with them all being wired in parallel, enable us to have the final 2 wires combined into this connecting cord, which will just come out the heel of the shoe, and it makes the overall packaging much easier than we had originally designed. We chose the small LCD screen over the large LED screen because it enabled us to meet the therapist's need for a more portable device.
The wireless system used to transmit the force readings is pretty basic. It uses a Schmidt trigger in the ankle pack and a receiver in the wrist pack. And the importance of it is it allows us to separate the display from the electronics that are located in the foot. That way, the display can be read on the wrist or in a handheld device by the physical therapist or the patient rather than having to look down at the foot itself or at the ankle pack, and allows for easier usage and better safety during therapy sessions.
My biggest takeaway from this project is the incredible problem that packaging poses to modern electronics. We got our main circuitry working fairly quickly on breadboards, we had a major problem trying to condense everything into a smaller size. So it's really impressive how some modern electronics can be so small.
I think my biggest takeaway from the project is simply just the teamwork.
My biggest takeaway from the project was the ability for us to learn how to do things we weren't familiar with. Like,
One thing I took away from this project is how crucial it is to stay organized and
I'm most proud of our team and the tenacity that our team had throughout the entire length of the project.